When an enterprise processes thousands of individual billing records, whether from prepaid plans, metered usage, or flat subscriptions, that data needs a central point of convergence. That convergence happens in SAP Convergent Invoicing, or CI. Convergent invoicing aligns, structures, and calculates these incoming streams to generate unified invoicing documents. This process represents a strict system boundary. It is the exact moment where a raw informational billing record crosses over to become a legally binding financial entry. The destination for that financial entry is the FICA subledger, Contract Accounts Receivable and Payable. For consultants configuring and testing this data pipeline, executing the invoicing process requires making a deliberate binary choice before hitting the execute button. The first option is the update run. This is a live execution that establishes a permanent financial reality in the system. The second option is the simulation run. This is a temporary, isolated execution used entirely for testing logic. You can see this architecture directly in the SAP Easy Access menu tree. The transaction codes for creating these invoicing documents are categorized by their execution type, whether you are running parallel processing, mass processing, or online processing. Technically, this order is classified under the source document category InvBI. During step 1 of the CI pipeline, data selection, the system grabs these InvBI orders. It groups them together into an invoicing unit that is tied to one specific contract account. Next comes step 2, document processing. Here, the system links the individual billing items together and derives the necessary posting rules for FICA. If you have configured additional functions, like complex payment card clearing logic to match a credit card transaction to the invoice, the system evaluates that logic perfectly in both scenarios. Up to this exact moment, the simulation operates as a perfect mechanical mirror of the update. It executes the identical underlying configuration logic. That identical pathway shatters at step 3, the database update. On the right side, the update run pushes data down. The system writes a real invoicing document directly to the permanent database. As this schematic illustrates, the system executes summarization and account maintenance and outputs actual posting documents straight into FICA. This commit has an immediate consequence. The original invoicing orders have done their job. They are consumed and permanently deleted from the processing queue. Now look at the left side, the simulation run. Instead of writing to the live database, the system generates a simulated invoicing document, categorized as document type Z3. This quadrant grid clearly maps the boundary. There is a hard barrier separating the simulated invoicing process on the top row from the live invoicing process on the bottom. They exist in entirely separate operational tiers. Because of this barrier, the simulation obeys a strict rule. No posting documents are ever created in FICA. And because no financial commitment is made, the original invoicing order is not consumed. It is retained intact in the queue, waiting for a real execution. Crossing this commit threshold dictates whether your action is a harmless sandbox test or a permanent financial reality. This divergence in database states completely changes how you handle errors. If you attempt to reverse a document generated in the simulation column, the system will reject it. You cannot reverse a simulated document because there is no ledger entry to unwind. It is a non-binding artifact. Simulation documents serve as logic validation tools. They allow you to verify configuration results and generate invoice print previews without affecting the ledger. But even that preview is isolated. If you look at this generated invoice, the stark gray test print watermark proves that the official print date and customer-defined fields remain entirely unupdated. Conversely, if you make an error in the update run, you cannot simply highlight the real invoicing document and hit delete. Real documents dictate financial balances. The FICA ledger demands a strict, traceable audit trail. To correct a live error, the document must undergo a formal document reversal within FICA, creating a corresponding reversal document to balance the ledger. This formal reversal protocol cleanly unwinds the math and releases the original source documents back into the queue, making them eligible to be invoiced again. Simulations provide consequence-free visual previews. Update runs enforce strict, auditable accounting protocols. We can synthesize this trace into a single matrix. Consumes invoicing order? Simulation no. Update yes. Posts to FICA? Simulation no. Update yes. Generates print preview? Simulation yes. Update yes. Can be reversed? Simulation no. Update yes. The simulation run acts as a read and preview operation. It allows consultants to evaluate complex underlying logic, like testing whether a specific credit card authorization maps correctly to an open item. This is done purely to validate the configuration behavior. The update run is a write and commit operation. It permanently transitions the state of the data, binds those financial results to the subledger, and forces any future corrections through formal accounting channels. Consultants utilize simulation runs to validate complex architecture safely. This verification step ensures the logic is correct before the system permanently binds data to the financial reality of the FICA ledger.